Well, good morning. Thanks for having me here. I'm really excited to spend a few minutes this morning talking to you about what we're doing at IBM around serverless and to talk about OpenWhisk. We're going to cover a whole bunch of stuff today. I want to start, maybe you'll indulge me for a couple of minutes. I know that we're in the morning of the second day of serverless, so hopefully most of you in the audience know what serverless is by now. If not, raise your hand. Yeah, I didn't think that would work. Let me just spend a couple minutes giving you kind of my perspective on what's going on in the industry around serverless and some of the growth that we're seeing, and then we're going to kind of dive into what we're doing with OpenWhisk and IBM Cloud. I think we've been on this evolution for a number of years now in development, where we're really trying to focus on the things that developers care about. We want to focus on the code and the applications that we're writing. And over time, we've kind of shifted from the early days of computing where it was all about the physical computer and the machine, and your application was kind of the 70th step in the process of setting up the environment. You had to set up your machine and set up your software, and eventually you got to your application. And through virtualization, we got a little bit closer with VMs, where we didn't have to worry about the hardware quite so much, but I still had to worry about the kind of whole machine image. In recent years, we've seen the rise of containers as a model that gets you one step closer, where now I can really worry about the software only, and I can worry about my application code and its dependencies, and I don't have to worry about the operating system and the environment. And I think serverless and functions is kind of the next step in that journey that says, well, I don't even want to worry about the software. I just literally want to worry about the code that I'm writing in response to a certain action or event that I care about. And so that progression, I think, is a good thing for all of us. I think it's all driven by a desire to be able to move more quickly, a desire to focus on the application development that we're doing and the problems that we're solving, and worry less about the infrastructure in the environment. And so with serverless, we of course have the value of no server, no infrastructure, just code, and we all love that. And it has some real benefits that we talk about a lot. We've talked about a lot in the last 2 days around simplicity, around scaling, around resiliency, that those kinds of problems kind of get solved for you by the infrastructure that your function runs in. For me, the more interesting thing about serverless is not actually the serverless dimension, but the event-oriented capability of serverless. The idea that I can simply write functions in response to events, and there's lots of workloads that we create that are fundamentally event-oriented. You know, if you look at the rise of IoT and sensor data flowing off of IoT devices, that's a very event-oriented workload where you want to do something when new data arrives or some action occurs within some sensor device. If you look at a lot of the stuff going on in the AI space around image processing and video processing, you know, you want to do something when you get a new image or you get new video or new data shows up within the system. Those are fundamentally event-oriented actions, and serverless is the easiest way to build applications that are that event-oriented nature. And so I think those two things, the simplicity we're getting from development and the rise of these kind of workloads we're all trying to solve, which have an event-oriented aspect, is part of the reason why we're seeing kind of this tremendous growth in serverless and functions as a service in the industry today. And just to give you a couple of tidbits on kind of what we're seeing, this is one snapshot of the functions as a service market and kind of where people are using function as a service applications. I think the message I take out of this is it's growing fast. We think over the next few years, the market size for serverless applications will grow tremendously. And in fact, if I look at the broader cloud space, you know, there's kind of two hypergrowth trends that are happening side by side in the application development space, and that's containers and serverless. And I think a lot of times we talk about them as if they're alternatives or that they're competing with each other. I think in many ways, those two models combined together, mixed together, will define the future of application architecture for the next decade or more. So we're seeing tremendous growth. I think we all know that. We're also seeing broad-based growth, meaning across industries, you're seeing growth across all the industries. And that's not surprising. I mean, serverless is fundamentally a horizontal concept. It's not industry specific. What you're really seeing is people who are forward-thinking within their industries, being early adopters to these kinds of technologies and building solutions. And later in my talk, I'll talk about a few examples of some customers we've been working with and the problems that they're solving. And I think you'll see whether it's a startup or a traditional bank, they're all finding value in serverless as an approach. So that's just a little bit of context about what I see going on in the industry around this space. Now, I want to talk to you about what we're doing in IBM. And I want to start with just a few minutes on IBM's cloud. We talk, there's actually a lot of capability in the industry across all the major cloud providers. Let's start with the basis of what we're doing. In IBM, our public cloud is called Bluemix. Bluemix is a full public cloud platform, globally deployed platform. It's full function, meaning it starts at infrastructure. You can get bare metal servers, you can get virtual machines, you can of course get containers, and you can run serverless applications. It's populated with a rich library of services. There's actually over 150 services in Bluemix, from analytics services to databases to video processing to Watson cognitive capabilities and IoT frameworks. Just this amazing menu of capability that developers can get access to. And I think the kind of third trend maybe in development right now is this idea of composition. We can build applications in containers or in serverless, and we can, from those applications, make use of services that get exposed in the cloud, whether that's databases or image processing or having Watson tell you how old you are based on a picture of you. And so Bluemix exposes all of these capabilities to developers. We do that, of course, in public cloud, deployed all around the world. We do that on-premise in some cases for enterprise customers who want to have a cloud experience but want to do that behind the firewall and inside their data center. And we do that in a model called dedicated, where we can have isolated instances for you that aren't shared with other users in the public cloud. And so into this broad platform, we've introduced our serverless capability, which is called OpenWhisk. So OpenWhisk is our functions as a service platform. And one of the things that defines the architectural approach that we've taken in Bluemix is to build our cloud on top of open technologies. At all layers within that stack that I showed you, where it makes sense, we've leveraged open source technologies, we've contributed in open source communities, and where necessary, we've created open source projects. Because we believe very strongly that when it comes to application development, the artifacts that you create, the APIs that you use, should be open, should be transportable across environments. You should be able to take that application and move it somewhere else, whether that's a different public cloud, whether that's into your data center. You shouldn't be bound into a specific environment. So when it came to serverless, a couple years ago, as we started our work in the serverless space around OpenWhisk, there was frankly a distinct lack of an open community around the serverless space. And instead of building something that was proprietary to Bluemix, we chose to create the OpenWhisk project. And we've donated that to Apache, and we build our serverless platform on top of Apache OpenWhisk. And we're collaborating with Adobe and others within that project to kind of build out an open platform for serverless development. And so Apache OpenWhisk is the foundation of our service in Bluemix. And of course, we take that foundation and we run it as a service within the cloud. And running it as a service means, of course, operating that environment for you, ensuring that as a developer you don't have to worry about, oh, I'm going to write my functions, but before I do that, I have to install and run my serverless platform. We do that for you. We handle scaling and resiliency and fault tolerance. We integrate it with our platform and security. We integrate it with the other services that are available in the cloud. And we manage that environment for you. So Bluemix OpenWhisk is the service built on top of Apache OpenWhisk. Now, when you think about OpenWhisk, there's a number of concepts that kind of make up how the system works. The first is, of course, events coming into the system. Events are the source that triggers the actions that you're going to perform within your serverless application. Triggers are essentially rules that take those sources, those events, and actually bind them into some action that you want to perform. We have a rich rule system that allows you to define complex rules about what sequence of events leads to the execution of which functions or actions that you want to perform. The heart, of course, of a serverless system is the functions themselves. We call those actions within Whisk. Actions are actually the functions or fragments of code that you run in response to those events. And of course, those produce results. And so you have this rich system where you can build a library of functions called actions. You have a rich library of sources coming in. And through triggers and rules, you can connect those event sources to your actions and build your serverless application. Now, like many serverless platforms, Whisk is a multi-language environment. We have support today within Bluemix for Node.js, for Java, and for server-side Swift. I don't know how many of you are also mobile developers and know Swift from doing iOS development. We've been doing a bunch of work with Apple to enable Swift as a language on the server side. So as a developer, you can use the same skills and same tools across the mobile side and back end of your application. We support that within Whisk as well, so you can write functions in Swift. We have some new things, like we're just recently introducing support for Python 3 within Bluemix. And then our platform is built on top of containers. And what that means for developers, you can also package up a serverless function as a Docker container. So if you have other languages you want to run, if you have other software dependencies that you need to bring in, you can actually implement the function as a container image and then insert that into the system. Will execute your container in response to the action that you're performing. Because OpenWhisk is done in the community, there are, of course, community efforts in the Apache project to add other languages like Haskell and like Scala into the mix. And so the community is building in additional support for languages into the platform. Whisk supports multiple invocation models. You know, serverless functions are fundamentally at their heart asynchronous or non-blocking invocations. There are some use cases where you might want a blocking invocation where you want the system to wait for the action to complete and return its result and not have to come back later to figure out the results. So we support a blocking invocation pattern. We also support a periodic invocation pattern where you can have a scheduled execution. So if you want to do scheduled work or a cron style model and schedule an action to execute periodically, you can define it to execute in that way as well. One of the things we're focused on is trying to make the system as powerful and easy for developers as possible. So there's some higher level constructs that Whisk supports as well. It supports something called chaining or sequencing, so you can have multiple actions or functions that chain together. I'll show you an example of that later. So if you want to kind of decompose your application into a set of reusable functions and then rewire them together into chains, you can do that very easily and do that through configuration. We also support something called parameter binding. This is essentially a model that allows you to say, my function takes a certain set of parameters. I want to bind default values to those parameters as part of the configuration of that action and not have to pass it in every time or hard code it within the code of the function itself. So if you had credentials or default values, you can configure those in Whisk as default parameter bindings and simplify the invocation of those actions later on. Of course, the heart of a system like Whisk is events, the event ecosystem. There's an open interface for event emitters within Whisk, so we can plug in new event providers. Through the community with Apache OpenWhisk, we're building out a library or an ecosystem of event providers that know how to generate events and feed them into OpenWhisk to act as sources for the functions that you're implementing. Within Bluemix, we have a number of providers already within the system. We have the periodic provider, which does the time-based scheduling. In Bluemix, we have a NoSQL database called Cloudant. It's based on CouchDB. So Cloudant is our managed CouchDB NoSQL service. We have support for that as an event provider into Whisk. So if you're building a database application, whenever data changes or updates get made in those data sources, those will flow as events into Whisk that you can respond to. We have integration with our mobile push service for mobile push notifications. We have integration with GitHub for GitHub webhooks. We have some new things that are coming that are just announced. We have a service called Message Hub, which is essentially Kafka messaging as a service within the cloud. And you can use Kafka as a source for events, which is a very flexible and generic mechanism to be able to feed custom events into the system. You can have applications that generate messages in Kafka, and then any of those messages can act as sources into your Whisk applications. And then we also have introduced something for support for something called App Connect. App Connect is a capability within our cloud to connect to applications and do integration between applications, whether those are on-premise systems or SaaS applications like Salesforce. We have built-in kind of out-of-the-box connectors and integrations with a huge suite of applications, and all of those can act as sources of events into your serverless applications. So we continue to grow that ecosystem of event providers that can flow into the serverless system. Now, one of the things that everyone loves about serverless is the pricing models that go with serverless functions, that you only pay for the time that you're actually executing your serverless functions on the cloud. When you're not doing anything, you're not paying for anything, there's no idle resources, there's no servers laying around that you're paying for even when no one's using it. And of course, you have as many of them as you need based on the load that you're experiencing right now. Same is, of course, true with OpenWhisk. On Bluemix, the pricing model that we use is essentially a combination of time and memory. So you're charged essentially gigabyte seconds of execution time. You can see what the charge rate is there. You can do a lot. I mean, if you just do the math, that's like over a day of continuous execution is like less than $2. This is part of what I think really attracts people to serverless as well, is this idea of being able to simply pay for the actual time that you're doing useful work. And that actually helps a lot with periodic workloads or more sporadic workloads where maybe there's long periods of time where there's not a lot going on. During those times, there's nothing going on in the system and you're not paying for anything. So that's just kind of a fly-through of some of the capabilities that exist within Whisk. Let's talk a little bit about kind of how it's put together. If you look at the Apache OpenWhisk project at a very high level, architecturally, there's a couple of major components to the system. Nginx is used as a gateway for REST traffic coming into the system. There's a controller who's really the heart of Whisk. That's the guy who has to figure out how to wire events to functions, that has to evaluate the rules that you define, that has to decide how to trigger things and what functions to execute. Once we've decided how to dispatch the event onto a function, then of course that flows into a Kafka messaging system that's distributing that work out to a pool of worker nodes that are invoking those functions. We invoke all functions in Whisk inside of Docker containers. I'll talk later about some of the work that we've done to really optimize execution around those Docker containers. But fundamentally, whether you're using straight language support like node support or whether you're bringing your own image, those things all execute on a pool of workers inside of a set of Docker containers. If you compared this architecture at a very high level to what we're doing in Bluemix, so this is kind of how it works if you went to Apache OpenWhisk, downloaded the environment, and installed it yourself somewhere. How do we do this inside of Bluemix? And structurally, it's actually the same thing, because of course we're based on that technology, and we don't totally do it differently in our public cloud, but there are differences. So one of the differences is instead of using CouchDB directly as the store, we use our Cloud service, so we use our managed database service as the data store behind Whisk. We run this as a service, so we integrate it with the rest of our platform, with identity, with our logging and metrics services in Bluemix that allow you to get visibility into performance and get log data out of your actions that are executing on the platform. We integrate it with the rest of the Bluemix ecosystem, so you can use Watson and IoT and all this 150 services that I mentioned. And of course, we run it at a much larger scale, right? We run it geographically in multiple zones around the world. And we run it in a multi-tenant way, right? So as you come into Bluemix, you can deploy and manage your actions in that environment, isolated from other users who are using the platform as well. Now, we've been hard at work on Whisk. We had it in beta a little over a year ago. It was a generally available capability of Bluemix towards the end of last year. And we've been constantly adding capability into the platform. I want to talk about a few things that are new that we're doing. One of the big ones that we announced this week is support for API gateway. So one of the really common use cases in serverless is wanting to be able to expose functions as APIs that people can use and consume over a REST-based API paradigm. And when you expose something as an API, especially if you want to expose it externally, there's certain problems that you have to solve in that API. Besides the actual construction of the API itself, you also have to worry about security. You have to worry about things like rate limiting and like who can access that API, how frequently can they access that API, how much load can they put on me. You might want to do mediation of that flow and change parameters and take input values and convert them into something else. So you want some injection in the middle. You may want to be able to validate the data. You want to get some analytics about how people are using those services. All of those things are common API management concerns that you have whenever you expose a public API. And what we want to do is make it really easy for someone to use OpenWhisk to implement an API that has all those characteristics without losing the benefits of serverless, without having to resort to how do I manage my own gateway, how do I manage a long-running edge component that's responsible for doing all this and then delegating to my functions. I just want to write a function and have all this behavior added in. And so that's what we've done. We're going to walk through an example of that later, where it's really easy for you to define an API, map it to a set of functions, and we take care of all of those concerns automatically. So that's the API gateway. Of course, sometimes you want to do something just simpler, like I just want a web endpoint for my function. You can do that as well in Whisk. If I don't need the management, maybe I'm doing an internal endpoint that my application uses. That's simply one click in the UI or one extra parameter on the action definition. If you see in the bottom there, you just do --web true, and we will automatically expose a web endpoint for any action that you want within the system. Of course, Whisk exists in the context of a community and an ecosystem, and as our strategy is about being open, we also are open to other solutions to problems. That API gateway function uses our API management capability. We've also exposed Kong as a plugin to OpenWhisk, so if you want to use Kong, which is an open source API gateway, you can do that as well, and that's very easy to configure and leverage Kong as a function within your architecture on top of OpenWhisk. Now, we're here at Serverless, and so lots of you use the Serverless framework. We've done some work recently to enable OpenWhisk within the Serverless framework, to enable all of the assets of your Serverless functions to be packaged up together and deployed into OpenWhisk, and to enable the Serverless framework to understand some of our artifacts like rules and triggers and packages. And so we now have support for OpenWhisk within Serverless framework if you're using that. We also announced integration with PubNub. So this is another kind of source for real-time applications being able to use serverless, and we've integrated PubNub with OpenWhisk so that you can work with stream-based applications. You can do some delegation of function into the network and kind of leverage events flowing to and from PubNub within your applications. And then the kind of final new thing is we've doing a bunch of work in the community around developer tools integration with OpenWhisk and making it easy to write and debug and create serverless functions within your favorite development tools. There's some work going on with VS Code. There's some integration going on with Node-RED, which is our kind of visual IoT construction framework. And there's some work going on in the analytics space with Jupyter Notebooks that allow you to kind of use these functions from those tool suites. So the moral of the story here is amazing amount of activity going on, some really compelling capabilities being added into the platform. What I want to do now is just spend a couple minutes and show it to you and kind of work through a little bit of a demo. What we're going to do is give you a little bit of a flavor for what Whisk looks like within Bluemix and kind of how we expose the capability to you. And then we're going to walk through a specific example of using the API gateway to expose a serverless function. All right. All right. Can we get? Oh, we're in. We have to fix the. We're in dual screen mode here. Let me fix this real quick. Okay. And in full disclosure, I know you get bonus points for doing things live, but the network is not friendly this morning, so we're not going to do it live. Well, I'll walk you through what we're doing. So first, let's just look at OpenWhisk. So this is Bluemix. By the way, you can go to bluemix.net today. You can sign up for free. You can get access to OpenWhisk for free. You can do like quite a lot of free execution of functions within OpenWhisk. So I encourage you to go try it as we walk through these things. Within Bluemix, of course, you have this rich catalog. I've zeroed in here on the OpenWhisk section of our portal where you can get started building serverless functions. If you look at if you were to dive in, you can see there's a number of capabilities. If you click on the Develop tab, we have full support for actually doing creation of serverless functions within the web UI. Of course, you can do everything I'm going to talk about through the CLI and through your favorite editor. I'm going to show it to you this way just because it's more interesting from a visuals perspective. So within our portal, you can create serverless functions. You can manage all the actions or functions that you have. You can manage sequences. Here's an example of a simple function that uses takes a parameter of a city, goes out to Yahoo Weather, and gets weather data and returns that back as the output of the function. You can run those functions from here, so you could actually invoke them and pass in parameters and get results. If you actually dive into the configuration of the function, you can control attributes around the function. For example, you can control what the maximum execution time is that this function is allowed to execute before it gets killed from the system. You can control how much memory it's allowed to use. So you can put some gates on kind of how much this thing can grow, which of course affects performance, but also affects cost in some cases. So you have those kinds of controls. You have access to additional parameters about these functions, including the web actions thing I mentioned. If you wanted to expose this Yahoo weather action as a web endpoint, you can do that simply by checking that Enable as Web Action button, and now it has a URL that allows you to get to that over REST instead of just over events. I mentioned chaining of actions. You can do that within the system as well. This is an example of a chain that I've created, which has a kind of proxy service in the front that takes the incoming web request and does some massaging of it, and then an action that is making an update to my Cloud database. That's a chain that's been defined. It does the first one, then does the second one. If you define these complex chains, you can see them here. You can configure them and edit them. Here's an example of that one. Has a web URL. You can see there if you enabled it what it would look like. You can also monitor the execution of your serverless functions from Bluemix. So this is a view of kind of the visibility we can give you into the execution. You can see all the actions that I have. You can see how often they've been invoked. You can see how many have failed or succeeded. I have an activity log of all those invocations. I can click on those activities and see the results and the inputs. I see a timeline of invocation of how things have invoked over time. So you get some really good visibility into the basics of what's going on. You can, of course, dive into any specific invocation and look at the logs of that invocation, look at the metrics about how long it ran, look at errors, and debug the system that way. Now, so that's the kind of high-level interface to dealing with serverless functions within Bluemix. Let's walk through an example. So in this example, it's very simple. I have a service I'm trying to create, which just maintains a database of books. So it's a simple database CRUD application. I'm using Cloudant as my data store. So I have a NoSQL database which maintains a list of books. I can add books to the list. I can remove books from the list. Really simple. What I want to do is take that basic function and I want to expose it as an API so that that can be consumed by other services or other functions who want to maintain a list of books. And so to do that, I'm doing two things. First, I'm using a built-in package. So for Cloudant, we have a built-in serverless package that has functions that know how to do basic CRUD operations and respond to basic events within Cloudant. And so I'm using this built-in package. That's one of the advantages is we can build up this library of serverless packages that know how to deal with different systems, and that makes it easier for you to create these applications. The second piece is I need to define an API in front of that database package, in front of that set of functions. And so that's what I'm going to do. So I click on Create OpenWhisk API here in the UI. I'll get dropped into an interface that allows me to define that API. So first I'm asked for a logical name for this API. I'm going to call it the book list. Here. Then what I need to do is I need to define a set of operations. So what are the actual verbs that I can process on top of this API that I'm defining? So I click Create Operation, and I get asked for the URL, the path to the resource. So this is my resource for books. So the path is /books. The verb I want to process, which is get in this case, and the serverless function or action that I want to invoke in response to that API getting called, which in this case is called endpoint get. So that defines a mapping between a URL and the API and an action that I want to perform in response to that URL. I do that for get. I do it for post. I do it for delete. And when I'm done, I wind up with an API definition. So I have an API called book list. It has 3 operations on it, which are create, list, and delete. And they are all mapped to different serverless functions that are going to get invoked in response to those actions. Once I define the API, I can, if I wanted to, I could add extra functionality on top. So this is some of the API management stuff I described. I can require an API key. So if I want users of this API to be required to provide an API key, I can configure that simply here on what the key is. If I want to do rate limiting on that API, I could do that. So I could turn on rate limiting and specify for this API what's the max invocation rate that the API supports, or for each user, what is the max invocation rate each user is allowed to call against that API. I can enable cores. I can enable OAuth. So if I want to do social login to Google or Facebook or something, I can enable that simply by turning on OAuth. So all those things just become configuration parameters to enable on that API that I defined. So I now have the API defined. Here I get a view. We'll come back to this later when we've actually used the API. I can share this API, by the way, with others. So if I want to, I can enable sharing. I get this portal link shown at the bottom. You could hand that to people who want to use your API, and that link will give them all the documentation that they need to be able to know how to consume that API. And so they might see a view that's something like this that says, here's the book list API. It has 3 operations called get, post, and delete books. For each one, you can see the URL that you call and an example or multiple examples. You can actually get curl examples or language-specific examples of how to actually go and invoke that API. So all of this just happened for you because you defined the API you wanted and the serverless functions you wanted to map to, and we deal with all of these kind of management concerns for you. So I have this API defined. Let's go use it. So I'm going to use Insomnia to kind of drive that API. The first thing I would want to do is create a new book. And so to create that, I go in and pass in a JSON structure that describes the book. I invoke the API, get back OK. The book's been created. I go to list. I click send here. And I get back a list of books. In this case, I added a book called First. I already had a book in my database called Second Book. So you can see all the books that came back from that function. And then, of course, I can go in and delete a book, and I get delete. So not super exciting, I know, but it gives you an idea that doing that wiring and mapping, building those APIs, managing access to those APIs is really easy. And each of those functions is either a simple operation I'm performing, or in this case, actually is wired into an action in Cloud package that already knows how to do this for me. Right? So I didn't actually have to write any code to manage the thing itself. And if I go back to that API view, you can see that we're also capturing analytics about how that API is being used. So I have the serverless function view that shows me the invocations against all those functions, and I also have an API-based view that shows me how often my APIs have been called, what kind of response time they're getting on average, what the call rates look like, and other interesting data about the sequence of activity that's happening within the API that I've now exposed. All right? So that's just to give you a little flavor of using OpenWhisk. Of course, you can do everything that I described on the CLI. So there's a command line called Whisk, and you can list actions. You can create new actions to the command line. You can manually invoke actions. So as you're doing development and you're building a function that's going to get wired into a trigger, like I'm building a function that's going to respond to a change in a file and object storage. While you're doing development, you can manually invoke that action without having to actually make the event happen. And that allows you to kind of quickly iterate on the function definition and get it working. And then once you have the code working the way you want, then you actually wire it into the real events and run the full flow through the system. So you can do all those things through the CLI as well. So let's go back here. So let's talk for a few minutes now about what's going on behind the scenes. As I mentioned earlier, everything in OpenWhisk runs inside of Docker containers. Right? We execute the functions essentially as container execution. Right? So effectively, an action invoke equals run on a Docker container. It's awesome for packaging. It's awesome for isolation. It gives the flexibility of you being able to use Docker images as a packaging mechanism to build functions. There's one downside, which is that invocation of a Docker container from cold actually takes a long time. It takes probably about 300 milliseconds, right? So, in serverless, when you're doing this live during execution, like any latency in starting up that function and getting it to the point where it can execute is latency that's seen by the consumer of that action. So execution latency is really important. Cold starting a container every single time is not really an effective model. So we've done a lot of work to optimize how we do execution. And there's really kind of 3 stages that you might go through. The very, very first time a function is executed, effectively this will happen. We will Docker run an instance of that function, and you'll get kind of a cold start latency of roughly 300 milliseconds. However, after that, we actually keep those containers around in a pre-warm state. So the next time we do invocation of that function, we can actually reuse that existing container. So we can take that container. And remember, for language containers, things are a little bit different. So there's really, think of it as 2 models. If you bring your own image, then we're going to warm start that image and we're going to run it. But if you give me a Node.js fragment, like I showed in the UI, what actually happens is I provide the image, and we inject the code into that image, right? So that warm started container is kind of generic. It can run any Node.js fragments. So we can keep that around. We don't have to pay the start time on that for future invocations. We just have to inject your fragment into it, right? So we can get some performance benefit by using these warmed up containers. But we do one more thing, which is for specific actions, we also can keep the container image around for the action that you executed previously, and we can reuse that. So this is now a container that's up and running that already has your code injected into it, and we can just reuse that container. In that case, we can get incredibly fast reaction time to those events and get small digit millisecond invocation times. And so we've done a lot of work in the container management layer of OpenWhisk to get high-speed execution of container-based actions, really by getting deep into how the container systems work and by taking advantage of techniques like this that allow us to have a different performance spectrum to deal with and allow us to have very fast response time while still having the benefits of the abstraction that containers provide. So that's just to give you a little bit of insight into how it works. Now, we're also doing work in the community around integration of Whisk with container orchestration systems. Because the reality is what a lot of people want to be able to do is mix serverless functions and containers. And so you get questions like, can I run my Whisk actions on top of a container orchestration system? And so the community has done work like that. There's support now for Docker Compose. There's support for running on top of Mesos. And there's support in the works for running on top of Kubernetes. And of course, in these environments, you still have this performance issue that I just described to deal with. And so there's work figuring out how do we kind of get the best of both. How do we run in a container orchestration system, run next to container apps and have them share each other, and also deal with the performance considerations that happen. But the goal in the community is to enable container orchestration and serverless to work really well together. And so there's a lot of work there. In Bluemix, we actually just launched a Kubernetes-based container service, and so we're doing work to kind of bring OpenWhisk and our Kubernetes platform together and to allow those things to work really well. Now, I want to end with just a little bit of, well, what are real people doing with this? What are some of the scenarios that we've seen people using serverless? And of course, our goal with OpenWhisk is to allow you to build an entire end-to-end application using serverless, right? If that's the right approach for the application you're building, you should be able to do everything. Of course, build the logic and functions, expose APIs, integrate with data, leverage cognitive and AI, build IoT apps. You should be able to do all of that solely within a serverless paradigm using OpenWhisk. And so we kind of approach the problem with that perspective that this is an end-to-end platform that you can build a complete application out of. But it also can work within a more complex application architecture where you have a mix of serverless and other things. Serverless is, of course, good for certain workloads. It's good for event-oriented workloads. It's good for volatile workloads that you can break up into smaller, discrete pieces. It's good for sporadic workloads in addition to high-scale workloads. And so, there are certain use cases where we see people have more success with serverless than others. And we've done a lot of work in the community. We have a number of partners working with us now in OpenWhisk, in Apache OpenWhisk, whether it's Adobe or others, partners like PubNub that I mentioned. We also have a bunch of clients who have started to build some really interesting applications using OpenWhisk. I want to talk about 3 of them. First is SiteSpirit. SiteSpirit is basically a service that allows the travel industry to get access to imagery that they might use when they're building things like travel campaigns. What they need is the ability, they have a model where people upload imagery of their vacations and destinations that they're going to. And what they want to be able to do is very quickly take new imagery and make it available through their catalog. And to do that, they need to do a certain amount of processing on those images. They need to crop them. They need to resize those images into multiple formats and sizes, and then load them into their catalog. And so they're using OpenWhisk to accomplish that. They have triggers based on an image showing up in object storage. When a new image shows up in object storage, it kicks off OpenWhisk. Whisk does cropping and image resizing of those images. It updates metadata in their cloud database, which has their kind of catalog of imagery, and uploads all the transformed images into a destination object storage that is used to drive the site. And by transforming from their old approach, which was a more traditional VM-based approach, to serverless, they saw a 10x increase in the speed with which they can process their images, so they can get stuff into their catalog much faster. And of course, they do it at about 90% less cost to them. So it's more efficient and faster, which is always what we want, fast and cheap. The second scenario I think is really interesting. This is Santander. Santander is a bank, very traditional, large enterprise, a European bank, well, I mean, global bank based in Europe. They had an interesting scenario that they were trying to deal with, which was check processing. And so their traditional process was manual check processing. They're moving to automated check processing, which either occurs because a paper check has been submitted to a teller or an ATM machine, or because their mobile app allows you to take a picture of that image, an image of the check. And they wanted to be able to manage the pipeline from check submission to the actual deposit into the bank and the notification back to the user. And of course, if you think about that problem, there's actually a very non-linear load to check processing. Most people get their paychecks on Fridays, and on Friday they submit their check and they want their money so that they can go do fun stuff on the weekend. So they see a tremendous spike in check processing on Fridays compared to the rest of the week. And so they said, hey, this is a perfect scenario for serverless. We have a very event-oriented workload. I receive a new check, and I have a very inconsistent workload profile that I want to be able to run efficiently. So they built a pipeline using OpenWhisk to take the incoming check, to do some fix-up on the image, some cleanup and cropping on the image, to do OCR, to read all the data off the check, and then to integrate with their back-end system that did the actual deposit of that check into the customer's bank account, and then finally actions when that completed to send emails back to the customer to say, hey, we received your check, it's been processed and deposited into your account. And they were able to do all of that with OpenWhisk with a collection of serverless functions. They were able to reduce the cost that they have for processing those checks, and they were able to deal with that load in an incredibly efficient way because the serverless platform just scales automatically for them on Fridays and handles that load. So I think it's a really good example of a traditional enterprise taking advantage of these new capabilities to solve some real problems that they have. The final example is Articulo. They have a really interesting application. They basically write articles for you. You give them a couple of keywords about some topic that you're interested in, serverless and containers. And they go out and they actually build a summary article for you automatically in your style that summarizes news and information about that topic. So it's like a cheat for writers. Like if you're in the press here, like you don't need to write anything. You just like put in a few keywords, you get an article out, and you submit that. It's great. I wish I had this in school. And the way this works is they have a chain of functions. The beginning of the chain is whenever you enter the keywords you want to search on. Each of those keywords triggers a whisk action to execute. That whisk action goes out and crawls a set of data sources for each. So each keyword is running in a different action. And goes out and crawls a set of data sources, whether that's Google or other sources, finds information about those keywords, takes that data through another action, feeds it off to a service that does automatic summarization. So it takes a big article and it generates like a small summary of what was in that article. And then they collect all of that data back, and they have a final set of actions that composite that set of information into a single article describing that topic that's styled a little bit based on your style and personality that you can figure in. And the output is a 300 or 400 word article about whatever topic you ask them to do. And they do all that through serverless functions. It scales, of course, automatically based on how popular the things are, and allows them a very rapid development model where they can kind of introduce new capabilities into their pipeline. So a really kind of cool scenario where they're using serverless on Whisk to accomplish this. So with that, let me wrap up. We're obviously really excited about serverless. We are excited about the momentum in the serverless space. We're doing, I think, some really interesting work at IBM and in the community around OpenWhisk and building a compelling serverless platform as part of our cloud. If you're interested in Apache OpenWhisk, you can go to openwhisk.org. If you're interested in what we're doing in Bluemix, go to bluemix.net/openwhisk. I encourage you to check it out. And with that, thank you very much.